that you're ready for it when the first clicker question arrives. Before I start, any questions? No questions? Homework's too easy? I can work on that.
It's so hard we don't even know what questions to ask.
All right. So, yes? You had a question?
Never mind.
Yes?
The black grades, how come you mark down some of the black grades from the previous grades?
Okay, I think what happened is that there was one of the lab instructors who confused the directions. So the lab grades have this complicated scheme to make sure that people switch the scribe and driver. And you should double check that you get the right grade. When you're the scribe, you get 4 points. When you're the driver, you get 2 points. So double check if you ever got 2 points while you were the scribe, then you have a reason to complain. There's only one exception. There's a couple of exceptions there, I guess. But so as long as you and your partner, always alternate, and it's always just you and your partner, you should be getting 4-2, 4-2, 4-2, and the other one should be getting 2-4, 2-4, 2-4, and all is well. You were the scribe, yeah. If you were the scribe and you got marked down, you simply need to contact your lab instructor and say there must have been a mistake. I mean, it's easy for them to make a mistake, but that sounds like an accident. So in general, if you have an issue with those grades, see if your lab instructor agrees it was just an accident. Otherwise, send me an email and I'll have a look at it. Other questions? Yes? Is what? Yeah, homework 0 has been graded a long time ago. If you submitted homework 0 on time and it hasn't been graded yet, send me an email. Yes?
Okay, for homework 2C.
Yeah?
Okay, how we input the day class. Do we need to, in our 2C homework, do we need to import like the Java Lang object and the recording calendar? Left for or is that clean?
You should not have to do that. Let me demonstrate how that works. Let's run BlueJ. So let's make a new project. That was homework 2C, right? So I'll call it homework 2C. So I need 2 classes, the day class and homework 2C. So for the day class, we need to get it from somewhere. So it's in the companion code for the book, and as some of you have observed and discussed on Piazza, and I'm grateful that you did, it apparently is only on the instructor side and not the student side. So hopefully everyone now has a copy of it. Yeah, I yelled at my publisher about that. I mean, that's obviously wrong and stupid. So I have it here on my machine. I already downloaded it, so let me get it from there.
Can you put the source code on Piazza?
Any of you can.
There's a link to it.
But there's a link to it. You can just follow the link. Yeah. And you should just follow that link anyway and download everything, because this issue is undoubtedly going to recur in a few weeks with something else. The other reason that it's a good idea to download all of that stuff is some of it might be useful in an exam, and you don't know if your internet flakes out during the exam, so you definitely want to have everything local. And in fact, now that I think of the exams, you're not allowed to be online except when you submit it. So it is a good idea to gather this thing locally. Where was I? Oh, I need to find the day class. All right, let's see where I have it. So it's chapter 3. What was it, chapter 2? Chapter 3. Okay, here we go. Here it is. So we'll just copy it, paste it into BlueJ, and there it is. Now, the question was, do I need to import something? So let's write homework 2C. So I guess for that we should get the thing out in NetBrad. Just a second. This is homework 2. Final. All right, so we have to make a new day. How do you make a day? I don't know. Year, month, date, right?
Year, month, day.
So, all right, so it compiled without having to import the class, without having to import anything at all, really. And so when we look at what goes on here in BlueJ, you can see that we have 2 classes in this project. And so the homework class, this arrow means that it uses the day class. And the day class doesn't use anything. It just sits there by itself. The day class, when you look inside it, it imports a bunch of stuff. It imports Gregorian calendar. But that's when you use the class, you don't really have to worry about that. Okay, next question. Yes?
So for the homework, so for example, when we made a new color, do you want the actual variable name to be C, or could we just name it any?
Oh, you could really name it anything you want. It's just like in this particular thing here, I had a D1 and it was used. Oh no, it wasn't actually used anywhere. And some of them, it's used elsewhere, and you would have to consistently rename everything.
But would we get marked down for like naming it like instead of inbox, it's actually?
As long as you don't name it anything obscene or something, you wouldn't get marked down. No, you can name it any way you want.
Okay, thank you.
Yes?
Does NetBeans have that arrow thing that BlueJ does?
No. No, NetBeans doesn't give you any graphical display of what your classes look like. So BlueJ gives you this little kind of useful way of visualizing the dependency between the classes, and NetBeans doesn't have that. Other questions? Yeah. Okay, so let me look at the.
Does it like require any
I see. Let me show you another way of settling that question. So his question was, how does this brighter method work? So there's this nifty thing here in BlueJ where I can type Java code without actually having to compile it. It's called the code pad, and I believe it's a part of lab of one of the labs. It is, right? So let me just do this. And so color blue is new color. Well, let me not use blue, like gray. New color. I think that's kind of gray. And so let's see. Now this says gray. If I want to see what it looks like, I say toString. Why can't I say print on? I think system out. See what happens. Illegal character. Illegal character 22. Okay, it hates me. I'll do it in a different way. I'll say greater toString. And that turns it into a string, and then I see the string. So this is the color 100, 100, 100. So if I wanted to make it brighter, I say gray.brighter. And then I print it. And now it's brighter. What if I want it even brighter? I do it again.
So do I have to put that toString at the end?
You don't have to do it. I'm just doing it here so that we can see it. If I don't do it in BlueJ, let me show you what then happens. So I'll just do it like that. Then I can click on this little doohickey here, and then I'll also see it. But then, of course, no, I don't actually want to inspect it. I can drag it on the workbench, I guess. Can I do that? Let me see. There was a way of right-clicking on it. Didn't we do? You guys did this in the lab. How did you get this on the workbench? You double-click. And that's all that you can see. Because now this value here is not very useful. I want to call a method on it. I want to call getRed on it. Let's see if I can put it in a variable. Color Fred.
You can just put as many of those brighters right next to each other as you want
Yeah.
until you run out. But it doesn't save that into the gray unless you get gray equals 30.
Yes. So let me first of all. Okay, I'll have to figure out why my thing is broken. Illegal character 3. Okay, that's okay. So, color Fred equals gray dot brighter dot brighter. Oh, but again, let's see if I can print it. System out. Print on Fred. Oh, then it prints it on here. Oh, that's funny. Okay. And now I could make it even brighter. But at some point it's going to bump up against 255, 255, 255, and then it doesn't get any brighter. That's as bright as it gets. I mean, it doesn't get brighter than white. Don't believe those detergent ads. Okay, other questions? All right. So let's get back into the lecture. Is it? Okay. So at this point, this is an old hat because you've been working with objects for a couple of assignments. So what is an object? It's somewhat nebulous. It's this entity that you can manipulate in your programs by calling its methods. And so just about anything in Java is an object. The only thing that's not an object is numbers. For technical reasons, numbers such as 5 or 10 are not objects. Strings are objects. The thing that you use for printing, system.out, is an object. And so you should think of an object as like this little blob here that has some data inside. You don't quite know what that data is. Like if we, for example, in BlueJ, look at system.out, then here I can see it's an object, and I can click on it. And then there's stuff inside here. But if you ask me what all of that is, I have no idea. You know, what is, there's a output stream writer, a buffered writer, trouble. There's a public Boolean trouble in there, a private Boolean trouble in there. there's stuff inside here that I don't actually have any idea what it is, and I don't have to know in order to use it. I can use system.out and make it do whatever I want without having to know what's inside.
So everything in system.out is basically communicating with this monitor.
Yes, everything that you care about is the public interface, the stuff that you can use. And so I've made the public interface here in this picture with these little gears. So there's two little machines that you can use. You can use print on, you can use print. There's actually quite a few more that you can use, but those are the ones that we know so far. So you should envision an object as this little box that has stuff inside and that is able to carry out some amount of work. Now in Java, every object belongs to a class, and the class is the one that decides what one can do with an object. So as it happens, system.out belongs to a class called printStream. And you could have other objects of class printStream. We'll in fact see them much later in chapter 11. Oh, that'll actually be in 46b. So in 46b, you'll use other, so that you can print to a file, or that you can print out to a network connection, which sounds like a reasonable thing to be able to do. Right now, all we know is system.out that prints to the console, but later we will be able to print elsewhere. And so all of the objects of class printStream have a print method and a printl method. Similarly, all of the objects of class string have a length method, and so on that we'll look at later. So yeah, every object in Java belongs to a class, and you'll just have to know what those classes are to know how the objects of them behave. The class tells what all of its objects are capable of doing. All right, so a method is a technical term for some instructions that the object can carry out that access some of the internals of it. And so you manipulate an object by calling its methods. And every time you want to call a method, the syntax, we've talked about this before, you have the name of the object, you have the dot, you have the name of the method, and then you have the, inside the parentheses, you might have parameters. And the class determines what are the legal methods of an object. So here, the object greeting here belongs to the class string, and I can call length on it, because length is a method of the string class. When I try to call system.out.length, then that's not going to work, because let's trace this through. System.out is a method, is an object of class printStream, and let's look at the documentation of printStream really quick. So here is printStream, and here are all of the methods of printStream, and it has quite a few, as you can see, and mostly variations of printing, and there's some formatting, but none of them is called length. And so therefore, it's not possible to determine the length of a printStream, even though you might say, maybe the length means something, like how many characters have been printed so far. There's no such method, so we can't call it. The public interface of a class is a description of everything that you can do with that class. So that's what's published in these documentations. And it's also what you get when you right-click on a class in BlueJ. Then it says, what you can do with the day object. Actually, I need to make one so that you can see that. So over here I have a day object. And here, this stuff here, all of the methods are the public interface of the day class. Notice that for that homework, by the way, you're using the day class, and you can use it without knowing what goes on inside. So in fact, when you look inside how the day class is implemented, I have it. Then you look at this, and I'm kind of hoping that when you looked at this, you said, whoa, and closed it as quickly as possible. Okay, so you're not expected to know how this stuff works inside. Don't spend any time trying to understand how the day class does its job. You want to see how the printStream class looks like? No, of course you do. So let's have a quick look inside the printStream class. Linux. Lubuntu. It's like Ubuntu, but easier. So let's find PrintStream. And so here is PrintStream. And so someone implemented it, and I really don't want to ever see it again. So I can use a PrintStream object without actually knowing how it was implemented. All I need to know is the public interface. So let's visualize a couple more objects. So we've seen PrintStream over here, where it has mysterious data, a couple of methods. Here is a representation of two objects of the class string, and you see we have a name of a class, string. We have a couple of methods here, and here the data is probably not so mysterious what goes on inside a string. A string has to store its characters, and that's exactly what it actually does. So here I made it slightly less mysterious. Notice that when you have these two objects of class string, they both have the same methods. Because they both belong to the same class, you can do the same things with them. So if I have two strings in BlueJ, the same thing would happen. So let me make a couple of strings here. And okay, how do I? There was some way of doing this. Do I drag? Aha. Yes, so I just drag them over here. So you have two string objects. Now when I right-click on it, bunch of methods. When I right-click on this, same methods. Because they're both objects of the class string. There's lots of them, right? A string has 100 methods or so. Here I only show two because I don't have enough room for all of them. And you don't have to know all of them, by the way. It's something that beginners are always troubled by, that when you look at the API documentation of, say, string, and it must literally have 100 methods. Such beauties as offset by code points, which I'm sure you will never need to know. Region matches, which I don't even know what it does. I've been programming in Java for 15 years. I've never once used the region matches method.
Why is it repeated?
Why is it there?
The region matches and then why is that repeated?
Oh, why there are two region matches method? Let's see, there must be a subtle difference between the two. So let's see, this one here takes an ignore case parameter that the other one doesn't take. By the way, when this happens, one says that the name of the method is overloaded. That simply means you have two methods of the same name. That happens a lot in the PrintStream class. There's a whole bunch of methods, all called print, that can print different things.
How would you distinguish? I mean, how can it tell the difference between them?
Oh, if you call system out print of 42, then it says 42 is an integer, and then it picks, where is it? Then it picks this one here. So it looks at the one, it depends on what you call it with, and it picks the right one.
That it thinks for you.
Oh, yeah. All right, so a few more string methods that are useful. A very common method is length. When you invoke the length method on a string, it returns a number, namely the number of characters in that string. So if you have the string hello world, and you say greeting.length, then it counts and says there's 13 characters in there. Are there really 13? Yeah, with the exclamation marks, there's 13. Notice that the quotation marks don't count. The space does count. Oh, yes, the space is a character. All right, now I can call to uppercase on it, so I could call greeting to uppercase. And then I get an answer back, and the answer is everything changed to uppercase. Notice, however, that when I do that, the greeting itself doesn't change. So to uppercase does not change the greeting. It constructs a new string containing all uppercase letters. So now I have two strings floating around, the answer of greeting to uppercase and the original greeting. So just as when you call greeting.length, it doesn't change the string, I call it. It gives me an information about it, and then the string is still there. The same thing is true for uppercase. So calling to uppercase gives me an answer without affecting the original.
Can you combine the two uppercase with length?
Okay, so yes, if I wanted to know what is the length of the uppercase version, then the uppercase is still 13 characters long, which, if you think about it, does make sense, right? So, so one thing that I like about this little code pad thing here in BlueJ is that as you read the book, you can just kind of experiment, and if you have some idea, something that you want to try out, just like what he just asked, can I combine the two? Then you can just do it right then and there. You don't have to like write a new program. You don't have to make a project. You can just run these little experiments. So originally BlueJ was made so that everything you do with these little bubbles, and the bubbles are great for getting an intuitive feeling for what the objects are, and so we've had a lab with that. But when I actually want to experiment with something, I just often pop up BlueJ and just write a few lines of code inside this thing, just so that I don't have to write a full program, and I still get to be able to try out a few things. And this whole idea of trying stuff out is a very powerful and useful one. There were a couple of people who said, gosh, the homework, seems so undirected. It seems so random. There's no recipe for it. There's no sequence of steps that you need to follow. And the sad truth is that's the way it is. That one could come up with a sequence of steps for these very simple programs, but pretty soon the programs get so complicated that there simply is no cookie-cutter recipe. And let's face it, if there was a cookie-cutter recipe, no one would pay you $80K a year for being a beginning software engineer, right? Instead, they would ship it all to somewhere where one doesn't have to pay anyone anything much at all. So it's good for you that there is no cookie-cutter recipe, but it does mean that you're going to have to be in this mode where you constantly experiment. So asking these kind of questions, what happens if, is really a good way of learning.
So you can add methods to the context after the object itself.
Okay, yes, oh, you can change those method calls, absolutely. The only thing that's important is that the output of the first one has to be something that matches the expectation of this one here. So if I were to call greeting to uppercase dot print on 42, for example, that wouldn't work because greeting to uppercase is a string, and a string doesn't have a method called print on. So as long as the chaining is legally possible that the next thing takes what the previous thing spits out, you can do it as often as you like. One doesn't usually do it more often than once or twice, because at some point it would clearly get unwieldy, but it is something that's commonly done. All right, so we have a question.
Yeah, so that one that you would just change it to a variable, right? And then you can print it. Like reading to uppercase, like if you make the reading to uppercase into a variable, then you
I could capture it in a variable and say string S3 equals greeting to uppercase.
could use print on.
Then I could use system out print on. Yeah, but that's completely different from,
Well, I was just
right? Because now it becomes a parameter of, oops, but then it now becomes a parameter of the print on method that is applied to system.out.
well, I just wanted to see
Yeah.
how you could print it.
Yeah, oh, absolutely. So, and if I wanted to do this, it still wouldn't work. And it would say S3 doesn't have a print. All right, let's get going with our clicker question here. Just Piazza. Paste. And then make it a whole. One, two, three, four.
I have one question.
Yeah.
For the final one on the brighter demo, should our final result be like a blue box that secret?
Yes.
Okay, check it.
Yes. Let's pick this up when I'm done with this. When we're done with this here. Oh, that's. Yes. I'm sorry? Just gonna have to keep at it. Oh, I'm not on the wireless. So Piazza seems seems alive. So many answers we have. Well, I just have to hopefully get it to go by the next question. Now, the good news is that I have a much better spectrum of answers than I usually get. And the even better news is that the majority has the wrong answer. So let's see what happens. So name is the string Fred, and then when I print the name, then it prints Fred, right? So I know it has to start with Fred, but all of them do, so nothing has been eliminated. So now let's see what happens here. So now we call name to uppercase. Now, a number of people seem to think that that was not legal. Oh, actually, I'm wrong. So the majority did have the right answer. But it's perfectly legal because name is an object. It's an object of type string. And so you can call to uppercase on any string object. And just to show that it's legal, let's paste it into BlueJ. And it gives back a string name all in uppercase. So there's nothing illegal about it. Now, those of you who have had some C++, at this point the audience is supposed to hiss. Those of you who've had some C++, they were probably the ones who thought it's not legal because in C++, for arcane technical reasons, this is in fact not legal. You can't call a method in C++ on a string. But in C, you can do it just fine. No, in Java, you can do it just fine. So this is not a problem. And it gives you the uppercase name. So that means it's going to print name, and this must be the right answer. So there are a few people who thought it printed Fred. Well, notice that there are quotation marks around the name, and that means it's the literal string name. It literally means name. It doesn't mean the variable. So if you missed those quotation marks, then you would have gotten this answer here. And if you missed the quotation marks and the fact that this is print and not print on, then you would have gotten this answer here. And apparently a few people did. All right, now I have 128 votes. What's that? Can I close it? I don't know. All right, before going on to the next one, let me quickly answer the question that someone had because that question did come up, and I just want you to see it. So the question was, what should happen in this homework here? So over here, when I say, I'll just change it, set it to pink. And now when you run it, then you just get this pink square. So all of this code here with the frame stuff, don't worry about it. That's just stuff that shows the color. So if I want to have it brighter, then of course I can easily do that. Well, that's a very bright pink. Okay. Let's see. Okay, so, and I want to hit it even brighter. And if your report looks like that, then you're doing the right thing, except it's not going to be green, right? It's going to be like some steel blue or some such color. Yeah?
Can you ever enter anything into those parentheses?
Can I do what?
For bright?
No, in brighter I can't put anything. And when you look at the documentation for it, let me show you the documentation real quick. Brighter. When you look at here, you see it says brighter, and there's nothing inside here. And that means you're not allowed to supply any parameters. So if you try, and it's easy enough to try.
So when it brightens it, does it brighten it up?
So let's say if I wanted to brighten it like 3 times, right? Then you get an error message.
You couldn't even do brighter 3 times after the
No, you can't. That's the fact that there's no parameter here means the method is not taking anything. It's taking no instructions.
So it only brightens it up 1 point at a time?
It brightens it up by, I don't know, but let's find out what the documentation says. Oh, it's a brighter version. It doesn't tell us by how much. I could find out by looking at the source code. Yeah. But the documentation doesn't, and so they designed it so that when you write a user interface, that if you have like a button colored a particular way, you might want it just to be a little brighter when the mouse goes over, that you have a way of computing that extra brighter color. Exactly how they do it is up to them. Okay, where were we? Oh, next clicker question. All right, let's hope more people are getting into Piazza now. Clicker question 2. Post. No. Yes. See what? Okay. Okay, I have 99 votes. I have 100 votes. All right, so let's see. So string name is Fred, name print-on, so that prints Fred. Name length is, that's 4, now it prints 4. So this one here doesn't do anything with uppercase, so that's bogus. This one here can't be right because it's print-on both times, so it must be 3, right? And I did manage to get 20 people into believing just that, so that's good. But actually, as most other people realize, it's a syntax error. Right? Why is it a syntax error? Because name is a string, and a string doesn't have a method called print-on. And length is an int, and an int isn't even an object, so it has no methods, and you can't call dot on it. So the syntax error is that the first case, you're trying to call a method that doesn't exist for this object. And the second one is you're calling a method on something that isn't even an object. And so both of them are wrong. Let's just verify it. I guess I'm just realizing that you could totally cheat on these things by just pasting them into BlueJ. And here you get a bunch of error messages, right? Cannot find symbol. And that's that. All right, parameters. So the gentleman in the front was asking this question. He said, when you call brighter, you can't give it any more information how much brighter you want. Anytime that you have a method and you want to give it more information on how to do its job, that extra information is called a parameter. So the print-on method has a parameter, namely the stuff that you actually want to have printed. And you feed it inside between the parentheses. The length method has no parameter because to compute the length, it doesn't need any extra information. It's already completely unambiguous. Now, the brighter method, it might make sense to have it designed so that it has a parameter. They just chose not to do it. And plenty of other methods, like getRed doesn't need a parameter. It just does its job without needing any other information. Of course, they all have the parameter that's to the left of the dot. Every method call has that because you call a method on an object. And so terminology, the thing that's to the left of the dot is called the implicit parameter, and we'll see in a couple of lectures why. And everything that's inside the parentheses is called an explicit parameter. So here we have the visualization of what it means to pass a parameter. It's drawn with these little arrows. So when the print-on method does its thing, then it gets this parameter hello world here. Okay, other terminology, return value. When a method computes an answer, that answer is called the return value. So the greeting.length call returns an answer. The answer in this case was 13. And that 13 comes out of the method. So here I'm having these little arrows that show how it comes out to visualize that. When the answer comes out, you can do something with it. For example, you can store it in a variable as it's done here. So it first calls greeting.length, the 13 pops out, and then the 13 is moved into the variable in here. So this is something that we've done several times today with the brighter thing and the to upper and length. You can chain these method calls. You can put method calls together. So here's an example on how we put two method calls together. We call greeting.length, and then we take that thing and pass it on to system.out.println. So here in the picture here, the 13 comes along. No, let's do it with a pen. The 13 comes along, and then becomes the input of the next method. Not all methods return values. For example, println does not return a value. It produces a value on the display, but that's different. So we can see that println doesn't return a value. When I type system.out.println 4, then I get a cryptic error message saying error void type not allowed here. Void means that nothing is returned, that no answer is returned. Do I have this? No. We'll see that terminology next time. So the system.out.println has, in effect, it shows something on the display, but it doesn't return a value that I could put in a variable. I couldn't say, for example, int n equals system.out.println. That would be an error because never mind that too, but
Besides
besides that. It says here incompatible types. That's because system.out.println doesn't return anything, and I can't put nothing at all into an integer. Okay, here we're going to look at a somewhat more complicated call. The replace method. So replace takes two parameters, two explicit parameters, the string to search for and the string to replace it with. So over here I have this river, which was Mississippi, and if I look for this string and replace it with that, well, let's see what happens. So river is Mississippi, and river.replace all right. So what am I going to do? Oh, whatever. That's why I'm computer science, not in English. Okay, trust me on this one. I'm not going to be able to type it in the dark here. So, and let's make another call. And let's change, all the S to a $sign. Then it looks like that. So you can see what it does. It takes all of the strings and replaces them. What if I want to remove all of the S's? Then I can replace all the S's by the empty string. And now they're all gone. So now you understand the replace method. And again, notice how nice and easy it is to do this in this BlueJ CodePad. You can just try out a few things. And after whenever you have a method that you kind of wonder what it does, just trying out a few things makes it usually pretty tangible what it does. Whereas when you look at the documentation, it's necessarily somewhat more abstract. But running a few experiments just makes it really, really easy. All right, so that's what replace does. So there's no method that lets you modify a string. So if you have a string and you want to change it, you can't do it in Java. Instead, what you have to do is you have to take the answer and put it into a different string. So you could say string no S's. And now this string here has the answer. So anytime that you want to modify a string, then you need to capture the output somehow.
Can you do river equals river?
Oh, absolutely. You could say river equals and now river has also been changed. Yes, absolutely. So that's exactly how you would modify it if that's what you wanted to do. Yes? River is a variable that points to an object. So let me draw the picture. So river is a variable, and it points to a blob. That's the object that has now Mississippi in it. And it's an object of type string. And so now what happens in the little code segment that we just had, I called replace on this fellow here, and replace constructed a new object, also of type string, that contains whatever that thing is, without the S's. And then when I said river equals, then now river refers to that thing and no longer to the old one.
So is that a pointer?
Yes. So it's technically called a reference, but it is the same thing as a pointer. So every time that you have a variable in Java, the variable does not contain the object. the variable contains the location of the object. And you can replace that location. You can say, now I want the variable to refer to a different object, and you simply say river equals, and then whatever that new object is.
So the variable is not like a directory or a file that you're putting the object in. It's just like a shortcut to that.
Yeah, that's a good way of putting it. It's a way of locating the object. It's a shortcut to it, yeah. So it contains the location of the object. And it's a variable, so it can vary. It can refer to a different object later. There was some other question somewhere? Yeah.
So if you want to bring out the address of the object, how can you do that?
You can't. So there is no way that Java will not tell you where it is. It manages it somewhere internally, and you can't get at it. And that's just as well, because that way you can't corrupt it. Other questions? Okay. All right, so this is a more complicated call because it has two parameters, two inputs, and it has an output. It's about as complicated as they get. Notice that I can, by the way, chain these, so I could perfectly well say river replace all eyes with exclamation marks, and I also want to replace, I'm not having many things left over here, all m's with two m's. And so then it does the first replacement, returns a string with that, then it makes a second replacement on the partially changed string and returns that. All right, just a terminology question here. This one's supposed to mean 1 here. Yeah? Yeah?
While everyone's voting, someone on Piazza mentioned, is there a way to import the whole day class into the Java library for future use? Can we do that?
So for future use?
Yeah.
No. No, you can. That would be a bad idea. So you can make your own library, but you don't want to put it in the standard library. But yes, you could make your own library that contains stuff that you generally like, and then carry it with you. And when would you learn that? In 46B. Yeah.
For the replace method, so for example, for the river, the example you gave earlier, so if you type in river, Java replaces whatever so it outputs whatever you want it to replace. But if you type in river again, it would go back to the original.
As long as you didn't change it, river has not been changed. So, so when you look at a call like river.replace foobar, then it looks up what is the object to which river points. That's some blob. It asks that blob to spit out the result of the replacement, which is a new object, brand new object, never seen before. And so the original object hasn't been changed, and what river points to hasn't been changed. So a method call generally produces a new result. So these method calls don't change the original. Same thing with brighter. When you call brighter on a color, you get a new color. It doesn't change the old color.
Yeah, use the original as kind of a prompt to display something.
In that case, you want to say C equals. Or you want to change it and say color C2 and then change that C to C2. I'm perfectly aware of that. I was hoping that some of you would notice that it doesn't work and then start thinking about why. All right, how are we doing here? Okay. So the vast majority of people says it's choice B. It has one implicit parameter. That's this one here. That's correct. It has no explicit parameters. There's nothing inside the parentheses. And it has one return value, namely 13 or whatever it was. Yeah. Yeah.
So when you have cells with grammar, why do they still use parentheses?
They just do for consistency. There are some languages where, in that case, you don't have to use the parentheses, where they're optional, or where you may not even be able to use them. But in Java, they just say the general pattern is implicit parameter dot name of the method and then the parentheses. And it's kind of useful to aid the eye. That way you know it's a method call. Later on, we're going to see that there is this thing without the parentheses that is something slightly different. It's a variable access. And so they just want to make it very clear to the programmer, it is a method call. The parentheses set that optical signal. A method is being called. So it was a conscious design decision when they designed the language. All right, so moving on. Sure. This is such a great question. All right. So let's see. So we start with Fred. Oh, that's this extra wrinkle here. That so we're storing system.out in this object out. And so if I want to draw that real quick, so if I have a blank screen, so we have name points to Fred. That's string. That's an object of type string. And we have out is another variable that now points to this print stream. And also system.out, which is a predefined variable, also points to the same guy. So that's the picture of the variables. So over here, we do out.println. So out is the same thing as system.out. Println is a valid method. So it's, there's no syntax error so far. So now let's see. Name.replace R with E. That returns an answer. And that answer is the string feed. Right? Replace R with E. Uppercase F. Okay, now that becomes the input, the implicit parameter of the next replace. So now this one here is told to replace E with O, and so the answer is food, glorious food. Then that one we call to lowercase, and the answer to that is now lowercase food, and that gets fed into, no pun intended, to println, and this thing gets printed. See how everyone did? Okay. Now, 30% said it was a syntax error.
Probably because I've never seen you use print stream.
Yeah, what was the syntax error? What bothered people about those 30%? Someone.
It was for me the print stream
Okay.
space out.
Okay.
I realized
So,
later on.
yes. So when one looks at the basic syntax, name of a class, name of a variable, it's perfectly legal, right? And it is the name of a class. And this thing here, system.out, is an object of type printstream, so you are able to save it in here. And so all you're doing with that statement is you're giving another way of describing that object. It's not commonly done, but it is perfectly legal. All right, finally, moving on to rectangles, a couple of minutes. So we have the important point here is, and I hope everyone has kind of internalized after the first homework, that when I make a rectangle like this one here, what it is, it's an object that has some numbers stored in it. So when I look at it in BlueJ, for example, because I didn't import it. All right, so it is an object, and it's not a rectangle, right? It's an object. It has stuff inside it. I can inspect it, and it has numbers inside it. So it is a little packet with numbers. Why is it called a rectangle? It's called a rectangle because it describes a rectangle. It has methods that let you do computations with rectangles, such as the one that you used in the homework that computes the intersection of two rectangles, which is a typical operation that you would want to do on rectangles. So notice the use of the new operator. New means that you construct a new object, and with almost all objects, you put them into life with a new operator. There's only a couple of exceptions. One is strings. Strings don't need a new because you just can use the quotes. And the other one is objects that you already have, such as system.out. Someone already has called new on the thing that system.out references, and so you don't have to do it. But generally, when you make a new object, you call new. So new color. The new makes the new color. An exception, a predefined color. That one already exists, you don't call new. But every time that you want to bring a new object to life, you call new. Okay, construction parameters shouldn't be particularly baffling. It's what new needs to know what kind of object you want. As it turns out, many classes, such as rectangle, have more than one constructor, and you can construct a rectangle by just saying new rectangle without anything. And when we do that, then we get a rectangle. Kind of hard to see what it does, so let's print it out. Print on new rectangle. And then I get a rectangle that's going to be the most useless rectangle ever with width 0 and height 0. But I guess if you give it no other information, what else can it do? All right. You can look that up in the book. And I have a clicker question that's somehow gotten lost. Well, we're out of time anyway, so you can ponder that at home. That's all I got. We'll regroup on Monday. Put questions on Piazza.